Um, so here's what we got, okay? Kaylee is firing a toy rocket from a building top, okay? The equation that represents the rocket's flight is h equals this, where t represents the time in seconds and h represents the height of the rocket in feet, okay? So these are almost like your let statement. Remember, like in the linear section, we were creating let statements. We're going to say, let t represent the time in seconds and h represent the height of the rocket in feet. We say that stuff so that when we get to the very end of the question, we can revisit what the variables actually stand for, right? So I can make a concluding statement based on what the question's asking me, right? That's why I've selectively, I've chosen the variables that I have on purpose, right? H for height, T for time, okay? But don't forget, like, this is no different than y equals negative 2x squared minus 40x minus 250. There's nothing different. Okay? Maybe you have any questions? Okay, so this is the equation that represents the rocket's flight. Okay, it looks very much like standard form. Okay, if I were to write this in standard form, I wouldn't want the bracket sitting there, and so in standard form, if I was to write this, I'm going to write it like this. I'm just going to distribute the negative into all three things inside the bracket, right? And so I'm going to get the equation that looks like this. Negative 2t squared minus, plus, because a negative times a negative creates a positive, plus 40t. And then the negative times the negative 250, that's going to be plus 250. Okay, so here's your equation written in standard form. And we talked about what standard form was good for. Right, and I suppose with this question, what I'm trying to do with this question is to like highlight everything that we've done over the course of the quadratics unit so far, right? And say, okay, standard form tells me one thing in particular, right? It talks about the y-intercept. Y-intercept and the direction of opening, right? We talked about that too. Right, and so if this was just an equation on a page, you guys would be able to look at this and say, okay, what's the y-intercept? Sorry, we'll look at this one. Okay, I'm looking at the standard form of this quadratic, and I want to know what height was the rocket fired from. Well, that's my c value, right? So if I were to write underneath here, y equals a t squared plus bt plus c. We said the y-intercept is going to be our c value. Right? So our y-intercept with this question is going to be 250. Right? So y-intercept is 250. What's this mean relative to the question? Well, we just apply our math, like the math concepts that we've learned, and then we just take what our answer is and relate it back to the question. Well, the question here is like, from what height was the rocket fired from? Right? You can say, okay, well, that sounds like my y-intercept, right? So the rocket, and I'll do this in another way in a second. Okay, the y-intercept is 250. We know that this is going to be the height. Now, if somebody could, in the chat, just quickly, I'm just going to ask a question. Can somebody tell me, and I'm going to prove that this is the answer for part A in a different way, like a math way. Okay, I want somebody to put in the chat for me, before I fire the rocket, what is my time value? Can somebody please tell me what the time value is before I've fired the rocket? Okay, and I'm going to pull up the chat here. So I want is it t equals 10? Is it t equals 0? T equals 5, 10? 15. What is the time value before I fired the rocket? Anybody? So keep in mind when like if you're running a race, whatever it is, nobody's starting a stopwatch before something's happened, right?
Wait, that's 0t squared and 0t, or is that B and A?
Are you talking here?
The Y, yeah, right there.
Those are
Those
just
zero.
I just underneath there. I just wrote out the general form of standard form. So just a at squared plus bt plus c.
Okay.
Okay. Just to highlight Zach there, like that the c value was 250. Okay. Now nobody's answered the question yet. So before I fired this rocket, has anybody started the stopwatch? The answer is no. Right. So if nobody started the stopwatch, then t is going to equal 0. Right. This is our like initial value. Right. It's like if t equals 0, I want to find out what h is. Right? We know how to do this. It's just a more complicated equation. Right? You're going to take your equation. You're going to say, okay, well, h equals, I'm going to plug in t equals 0 into the equation. And I'm going to see what number comes out. Well, let's do that. Negative 2 times, what's t? T is 0. 0 squared plus 40 times 0 plus 250. Well, 0 squared is 0. Plus 40 times 0, that we already know that's 0. Plus 250. Negative 2 times 0 is also 0. So you have two zeros, so h equals 250. Right? We say initial values, right, or the initial time, right, h equals 250 feet. So we know that the rocket got fired from 250 feet in the air. Is everybody okay? Okay. So everybody should be able to do this particular question. Okay. I will probably give the academics a question that is exactly the same. The equation is just different. And they have a skill to deal with a different question that took 2 or 3 extra lessons to get to, right? They have it's still factoring, it's just a different kind of factoring, right? And so they can deal with this question no matter what. It doesn't matter what the equation it is I give you. They can deal with a question like that. For the applieds, that's not in your curriculum. But you guys have to know how to produce this graph, right? And answer the word problem. And we all have to know how to do that. Okay, so here's the second question. How long would it take for the rocket to hit the ground again, right? So basically what I like to do sometimes is I draw my picture. And here's the question, right? We're up here, I don't know, maybe we're on the roof. We're on the roof of this building or something. And we fire this rocket. It's going to go up, and then it's going to come back down again. This question, part B, is asking us, how long, time-wise, does it take for this rocket to hit the ground? Right? If it starts 250 meters in the air, that's what we want to know. Right? The thing is, I've been provided in the question something that looks like this. Okay? How do I know that this parabola it looks like this graph? How do I know it looks like that and not like this? I know that because of the negative that's out front, right? The A value is negative, so it's telling me that the parabola is opening down, right? So I know it's opening down, it's frowning. That's because of the negative that's out front. Okay? So, I'm okay on that front. I know that there's a negative there. Now, you all saw something that looks like this in the last few days. Okay? Now, the academics might be quick to jump to, I need two numbers that multiply to negative 500 and add to negative 40. And then you're going to find those two numbers at work. Okay? The academics might jump towards that because they saw something else. But the applied class is maybe, hopefully, looking at this and saying, I have no idea how to do one of these questions where there's a number out front. And that's fine because I haven't shown you how to do that. Well, we have talked about it though, right? But everybody should be able to look at this question and remember, I explicitly said, and I gave you some homework questions on this too, we want to remove the greatest common factor. I think when I look at that question, I think there's something in common in there that I could remove. I think I could remove a 2, right? So if I remove a 2, you're going to tell me what's left after I divide all of these by 2, right? Okay, well, you're going to get t squared minus 20t minus 125. You're going to close the bracket. Anybody have any problems with what's gone on there? We found the greatest common factor. We've done this. We've practiced this. Found the greatest common factor of 2. I suppose I should also mention that, just as a recap, because I know we've already done this, but keep in mind what it is we're trying to do here. We know what this thing is. This has a name of an X-intercept. It's where it crosses the x-axis. Right? So you guys are looking at it and thinking, how do I find X-intercepts? Well, I take standard form and I switch it to factored form. How do I do that? I factor. This will tell me X-intercepts. That's what you're after. Right? So that's what we're doing. We're just going to factor this and then see what happens. Right? So now you need, I'm looking at this, I need two numbers. This is a little bit of a bigger one. It might be a little bit challenging for some of you. I don't know. It's challenging for me too. I haven't done this yet. You're going to find two numbers that multiply to negative 125, but add to negative 20. Does anybody want to have a go at this? I'll give you guys a minute to look at this. This is not... Bailey's asking how to go plus 20 minus 20. Bailey, I revisited... Okay, it's a good question, Bailey. I was hoping nobody was going to ask it, but it's okay. It's a good question. If we look at the... Here, I'll scroll down. If we look at the equation written in standard form... it wasn't plus 125, it was plus 250. So if we look, this was the equation written in standard form, Bailey. If I wanted to find the greatest common factor on this, I would have found it to be negative 2. So then you ask yourself, okay, what happens, I don't know what I'm doing here. What happens when I divide everything by negative 2? Right? Because you said your greatest common factor was negative 2. So you can say, okay, h equals negative 2. I'm going to write that out front. Negative 2 divided by negative 2, that's just 1. 1t squared. 40 divided by negative 2, Bailey, should be negative 20t. And 250 divided by negative 2 is going to be minus 125. Okay, the reason why, Bailey, it's not plus still is because the negative was already removed when I started this question. Does that answer that, Bailey? So again, like, it just kind of comes down to you guys being careful with what your greatest common factor actually is. Okay. Okay, good. Okay. Can you guys, anybody, while we've been having that conversation, has anybody found what the two numbers are that work for this? The two numbers that are going to multiply to 125, negative 125, but add to negative 20. Okay, I'll save you some time. Like, you guys can run through this, no problem, right? You can go 1 and 125. You're going to be here for a bit, right? 2 won't go into 225. 3 might, but anyway, we're going to find that as you keep counting. Did somebody find it or no? I had a mic on. Everybody find the two numbers? 5 and what, Zach?
I don't know. I just thought 5.
Okay, we can, yeah, so you guys are going to run through this. You're going to go 2, 3, 4. Eventually, you're going to find 5. And 5 times 25 will equal 125. You'll see that, right? But the problem is, I need to equal negative, which must mean that one of these two numbers has to be negative, right? I don't know which one it is yet, but I know that one of them has to be negative, okay, in order for it to multiply to negative 125. So what you're going to do is you say, okay, well, what if I made the negative on the 25? Well, then you're going to see negative 25 plus 5. Well, that equals negative 20. But when I multiply these two together, I also get the negative 125. So I've satisfied both conditions, right? And then we learned, okay, well, as soon as I find those two numbers that work, in this question, it's 5 and 25, then I just write the variable in front of them, and I'm done. You go h equals negative 2 t plus 5 t minus 25. Oh, plus 25, sorry. No, I was right, sorry. I'm thinking about something else. I'm one step ahead of you guys. Guys, are we okay with what happened there? All I did was take it. It was written in standard form, like this. All right, it was written in standard. I factored it. All right, here it is in standard. I factored it using my man process, and it turned into factored form. Why do I write things in factored form? So that I can read off the X-Intercepts. Why do I care about the X-Intercepts? Because it's how long it took for the rocket to hit the ground again. That's what we're after. Right? So now you guys are able to say, okay, I'm going to shrink this down because I think it's kind of in the way a little bit. Okay. Now you say, okay, well, what are my X-Intercepts? Well, one of them is at t minus 5. Right? So negative 5 and 0 is one of them. And what about over here? Remember, it always takes the opposite sign. T equals 25. So we're at 25 and 0. Right? Well, negative 5 doesn't make much sense. I can't have negative time. Right? Negative time doesn't make any sense. And so what ends up happening is this is a mathematical solution that satisfies the equation. So yes, it is correct, but it doesn't make sense in the context of the question. So you get to ignore it. Like, we can't have negative time. Okay? That's not useful to me. But here, this one looks all right. It seems like it's going to take 25 seconds right? This is what you're reading off here, right? If I'm reading the point of intersection, or not the point of intersection, the x-intercept here is going to read off as being a t and an h. That's how the points read, right? Times on x, h is on y. So the point th is how that's reading. I'm going to get rid of this, it's in the way. Okay, so what's it reading? Well, when t equals 25, h equals 0. H equals 0, that's the ground. Well, how long does it take to hit the ground? 25 seconds, right? So therefore, it takes Does anybody have any questions? Okay, I remember on day one I said the most important thing is that we have 3 forms of a parabola and that we switch between them. That's what's important. And we switch between them so that I can find different information in context to the word problem. Okay? Now, what I've shown you so far is switching from standard to factored form so that I can read off the x-intercepts, right? But there's no limit to, remember we talked about all these key features, right, of a parabola. There's no limit to what I could ask you in a word problem. I could ask, all I'm doing is saying, how long did this take? Well, that's the x-intercept, right? How long did this take to hit the ground? That's an x-intercept, right? That's just a key feature, right? And it doesn't matter, for those of you in the academic class, it doesn't matter how complicated of an equation I give you initially. All I've done is I've provided you a word problem and I've asked you to solve for how long it takes to hit the ground, right? If that equation is really ugly, you guys have a couple other tools to use in your tool belt, right? If that's complex trinomials and factoring like that using decomposition, or if it's not factorable at all, I gave you guys an equation that would spit out the 2 time values. You throw in your ABC values, it spits out your answers. We talked about that yesterday, the quadratic equation. If it's not factorable, then you just use the quadratic equation. It'll spit out your answers. Okay? Does anybody have any questions? Okay? Now what I'm going to do is go down here and I want to talk about one of the other key features. Okay? So, let's go down here and we'll say, what was the maximum height of the rocket reached? Well, sometimes, you know what I like to do sometimes? I just like writing down, like, it doesn't matter if there's words there. There's words there, right? I'm going to relate it to what we've been talking about. Sometimes I just like making a summary list of things that I found, right? I know the y-intercept was, what did we say it was? 250, positive 250. So x value would have been 0 and y would have been 250. Well, sometimes I like making a list, right? And all I'm doing is going to go through all of these key features that we've talked about for a week now. Y-intercepts, x-intercepts, vertex, max, mins, all that stuff, right? Axis of symmetries. We're just run through that and see what I know and what I don't know, right? So we found the y-intercept. That was the very first question, right? What height was the rocket fired from? Then we found in the second question, we found the 2 x-intercepts. One of them was at -5 and 0, and the other one was at 25 and 0. Right? Now, after we found x-intercepts, we learned about, can I find the axis of symmetry? Right? It's the axis of symmetry that allows us to find the vertex. We did a whole bunch of this when we were producing the graphs, right? We found the middle of the x-intercepts, which told us the axis of symmetry. We took that value and we plugged it into the equation. It spat out what our vertex was. Okay? And then we can find out from the vertex the optimal value. And that's pretty much it. That's all we've spent our time doing, is reading off stuff like this. Right? So, let's take a look at what C is asking us to do. What is the maximum height the rocket reached? Well, if I look at my picture, my maximum height, a max, optimal value, maximum, occurs right here, somewhere, right? The maximum height is right here of the rocket, right? How long did it take to get to the maximum height? That's just a time value, right? How do I figure out what this is, or what this is? What is this thing called? It's an axis of symmetry. That's my axis of symmetry. If I find what my axis of symmetry is, and ultimately the vertex, I answer all of C. If I find the vertex of this parabola, I've answered C. What is the maximum height the rocket reached? And how long did it take to reach this height? Then you're done. That's it. You just interpret the vertex, and that's the answer solved, right? So let's do that right now, okay? I'm after this axis of symmetry. How do I find the axis of symmetry? Axis of symmetry we found by looking at the middle of the two x-intercepts, right? We know what the two x-intercepts are. They're just not on a graph. But I told you yesterday how to find them, right? Axis of symmetry was always, okay, well, here are the two x values. It's like an average of your marks, where you find the middle of your marks, right? You add up how many marks you have and divide by how many that there were there, right? So you're going to say, okay, well, I have 2 marks. One is at -5, and the other one is at 25. How do I find the middle of them? Divide by 2. Right? You say, okay, -5 plus 25, that's positive 20. Divided by 2, well, that's 10. My axis of symmetry? Remember, T is on the x-axis. This is your axis of symmetry. What did I do with that axis of symmetry, or that information, after I had it? Well, we plugged it back into our equation, right? Doesn't matter which equation I use, right? They all mean the same thing. They just tell us different information. But some of them sometimes might be easier to use than others. Like, I think this right here makes sense to me. Why wouldn't you just plug the t equals 10 in there? There's no squareds or nothing funny going on. You just plug t in. What's it going to find? H. Height. What height specifically? The maximum height. Right there. Right? So we're saying, okay, H equals -2 times 10 plus 5, 10 minus 25. Let's just do the math. That's it. -2, 15 times, what's 10 minus 25? That'd be -15. Right? So we get -2 times, I don't know what 15 times 51, what's it? 225. I think it's 225. Let's check. Yes. 225. Right? What's -2 times -225? it seems like if I were to write a therefore statement here, I would say, all right, therefore, the maximum height of the rocket is 450 feet, right? That takes care of the first part. What maximum height did the rocket reach? 450 feet. How long did it take to reach this height? T equals 10. It took 10 seconds for it to reach this height. Right? You guys can now fill out, look, you look at all the stuff you can fill out here. All we've done is answered questions about this. The vertex is at 10 and 450. What's the optimal value? Or I'll erase the box so I'm not constrained. There's the optimal value is, there's a maximum of 450 when t equals 10. You could even put some units in there now, right? 450 feet when t equals 10 seconds. That's you have answered this entire question. Very loaded, but I mean, we spent a week doing all this, right? And I think I've done okay. Like, I feel really good about, I don't know how you guys feel, and I can't see you, right? This isn't a normal classroom. I can't read the classroom at all, right? But I feel really good about what's gone on in the last, like, just in the way that I've taught it relative to the past, right? Like, I feel like I've taken you guys on a pretty nice story to get to this stage, right? Is there some stuff in the middle? Yeah, there's some harder stuff, right? And can we go off in different tangents on, like, factor all these and whatnot? Yes, right? But I feel, looking back at, like, the last week, I feel pretty good about where we started, how I introduced this topic, and kind of where we've ended up with this, right? I don't know if that's resonated with you or not, right? You guys can feel free to turn on your mic and say if you're completely lost or not, right? I feel okay with how that's gone, right? This is as hard as I can make this, aside from the academic students giving you a harder equation here, right? But this process is all the exact same for you guys. It doesn't matter what the equation is. I suppose that's the main difference, right? For the academics, it doesn't matter what I put there, right? It does not matter what I put here. It does not change the process from the top to the bottom of this word problem, right? You're still switching from standard to factor form. The only thing that changes is you're going to use a different kind of factoring, or the quadratic equation, right? You still are interested in the roots, you're still interested in the axis of symmetry, and you're still interested in the vertex, right? You're still interested in where the rocket was fired from, right? That's it. Okay, does anybody have any questions?